Okay, so let's go ahead and do the, Okay, so let's go ahead and do the following chart. So let's take a look at our examples. So this substance, just the letter O, well, what's the name of that substance? Oxygen. Okay, so is it an element or is it a compound? Okay, remember an element, those are on our periodic table. A compound, again, okay, it's two or more different elements. Well, kind of obvious, we only have one single element, just like on the periodic table, so it's an element. Now, is it an atom or is it a molecule? Remember, an atom is a single element. A molecule is going to be any bonded element, so it's more than one atom. Okay, so in this case, because it's just a single element, it's an atom. Okay, O2, again, it would just still be oxygen. Okay, now this time, do we just have an element or do we have a compound? Well, remember the definition of a compound is two or more different elements. We have two of the same element, so it's just an element. Okay, now is it an atom or is it a molecule? Well, it's going to be a molecule because we have more than just one element. We have two, right? We have a subscript, so we have two oxygens, which makes it a molecule. Okay, hydrogen, same thing there. Hydrogen, and is it an element or is it a compound? Well, it's just one H, so it's an element. And it's also an atom. Okay, we have another repeat. So we have another H2 similar to O2. So it's still going to be hydrogen. Okay, is it an element or a compound? It's going to be an element. Now, is it an atom or is it a molecule? Well, there's more than one, so it's going to be a molecule. Okay, so at this time, go ahead and pause the video. I want you guys to go ahead and try to do the rest on your own. So carbon all the way up to carbon dioxide. I went ahead and wrote the name of these three elements for you because you guys haven't learned how to name elements yet. So go ahead and pause the video and go ahead and complete the following. I'm going to go ahead and put the P up on the video. Okay, so this is what you should have gotten. So check your answers. Okay, so carbon, aluminum, chlorine, gold, those are all just elements. Carbon monoxide, ammonia, and carbon dioxide, those are all compounds. Okay, so again, if it's just a single element, it's going to be an atom. But if you have more than one element or more than one atom, it's going to be a molecule. Okay? All right, so let's go ahead and continue. Okay, so this is more like review. We've already gone over a lot of this stuff from our last unit. We've gone over valence electrons, we've gone over Lewisdot diagrams, but the new one that we're going to talk about is oxidation numbers. Okay, so again, it's a lot of just review information. Okay, so number one, how many total electrons are in a neutral atom of sulfur? Well, if it's a neutral atom, remember, the number of protons and neutrons and electrons are all going to be the same. Okay, so right off the bat you can tell, well, we have 16 electrons. Okay, well, if you didn't know that, you can also use your electron configuration to help you. Remember, with your electron configuration, your exponents are your number of electrons. So if you just add these numbers up, add your exponents up, you should also get 16 electrons. Okay, so number two, how many electrons are in sulfur's highest energy level? Okay, it's the most outer shell. So hint, use the picture to the right. So if you use the picture to the right, you would just have to count, well, this is the outermost shell. So 1, 2, 3, 4, 5, 6. So you have 6 electrons. Okay, another way to check, well, you have an electron configuration right here. Your highest energy level is the 3rd energy level. So again, you would look at your exponents to help you count how many electrons you have. So 4 plus 2, that's 6 electrons. Okay, number 3. How many electrons does sulfur need to gain or lose in order to have 8 valence electrons? Well, if you have 6 electrons, is it easier for you to gain 2 more or lose all the 6 that you have? Well, it's easier to gain 2. Okay, so it's going to be gain 2 electrons. Okay, so moving forward. Okay, recap on Bohr's atomic model. So Bohr developed an atomic model. Okay, so sorry. Bohr developed an atomic model in which the electrons are arranged in specific energy levels. Okay, so let's see. Okay, so in specific energy levels. Okay, so the lowest level the lowest level, if it decides to autofocus. Okay, so the lowest level, which is period 1, is going to be located closest to the nucleus, and the highest level is going to be located farther away from the nucleus. We can see that right here in our Bohr model. Okay, this is going to be our first energy level. So this is period 1 right here. And as we add energy levels, it's going to get bigger. Okay, or we just add the energy levels on the outside. Okay, so the electrons in the highest or outermost energy level for any element are known as valence electrons. Okay, oh, electrons is already on there. Okay, so valence electrons. So again, valence electrons are the electrons that are involved in chemical bonding. Okay, so when your atoms start to bond together, the outer ones, your valence electrons, are going to be the ones that are going to bond with other atoms. Okay, all right. So valence electrons can be easily found by looking at the group number. Okay, so group number. Okay, or the A number located above the column where the element is located on the periodic table. So if this is a column on your periodic table, okay, this is your group number, and then this is technically also a group number that tells you how many valence electrons you have. Okay, so if we were to look at aluminum, which is right here, okay, it's in group 13. Okay, and it's also in group 3A. Okay, so it has how many valence electrons? Well, 3. Okay, because remember, the number in front of the A tells you how many valence electrons you have. Okay, so if we were to look at lead, okay, lead on your periodic table, okay, lead is right here. So lead is in group 14 or 4A. Okay, so group 14 or 4A, so it has 4 valence electrons. Okay, so practice. So determine the number of valence electrons for phosphorus, argon, lead, and barium. Okay, so I'm just going to go ahead and tell you guys that phosphorus is in group 5A. So if it's in group 5A, then it has 5 valence electrons. Argon is in group 8A, so it would have 8 valence electrons. Lead is in group 4A. Okay, so we have 4 valence electrons. And then lastly, barium is in group 2A on your periodic table, so we have 2 valence electrons. Okay, so please remember that this only works for group A elements. Okay, so if we took a look at our periodic table, okay, these are your group A elements. So S block, okay, as well as our P block. Okay, so those are all our A elements. It does not work for our D block or our group B elements. Okay, so another exception to that little cheat or shortcut is helium. Okay, helium only has 2 valence electrons. So even though helium is in group 8A, okay, it still only has 2 valence electrons, not 8. So you do have to remember that. Okay, so practice. Label the valence electrons for each group A column on the periodic table to the right. Okay, so again, this is going to be 1, since that's group 1A. This is 2, 2A. And if I can get this, here, I can just open this up for y'all. Okay, so that's 2. This is going to be 3, 4, 5, 6, 7, and then 8. Okay, those are all going to be the number of valence electrons for each group, for each column. Okay? Alright, so moving on to Lewisdot diagram. So again, this is nothing new. We've already gone over this in a previous unit. Okay, so Lewisdot diagrams is a diagram in which the chemical symbol of an element represents the nucleus in the inner energy level, and dots represent the valence electrons. There can only be up to 8 valence electrons, and thus only 8 dots around a symbol. The first 4 dots are single, then they pair up as more are added. So that statement right there should remind you of the bus seat rule. Everyone wants their own seat on a bus, but once all the seats are taken, then they're going to have to start sharing seats. Okay, your octet rule, this is really important. Your octet rule states that all atoms wish to be like the noble gases in group 18 with the full valence of 8 electrons. Okay, remember you do have an exception. Helium is your exception with only 2 electrons. Okay, so how are the dots arranged? So treat this symbol as if it were a square with 1 dot on each side of the 4 sides before pairing them up. Okay, so you guys remember that in the center is always going to be our element symbol, and then on the outside, these Lewis dots are going to represent our valence electrons. Okay, so remember how we number our element. So let's say this is element X. So we are going to number it. There's my first dot, okay, or valence electron. There's the second, third, fourth. Okay, now all the seats are taken. So now they're going to have to start sharing. 5, 6, 7, 8. Okay, so does it really matter if I just started, maybe 1 could be here, then 2, 3, 4? It doesn't really matter where you start as long as you follow your bus rule. Okay, they want their own seat on the bus. They don't like each other. Okay, so they are going to sit by themselves up until there's no more seats available. Then they'll start sharing. Okay? All right. So moving forward, oxidation numbers. So this is what's new. We've never talked about oxidation numbers before, so this is the important part. Okay, so oxidation numbers is the number of electrons an atom gains or loses or shares when it forms a chemical bond and achieves the octet rule. Okay, so this will also be the charge of the ion. So as a rule, metals are going to lose electrons and will have a positive charge. Remember, we've talked about this before. If you lose electrons, you are going to become more positive because you have more protons, right? Nonmetals will gain electrons and have a negative charge. Well, if you have more electrons than you have protons, then that makes you a negative charge. Okay? And then noble gases in group 18 will not lose or gain and have a 0 charge. Remember, they want to follow the octet rule. They want to have 8 valence electrons. Well, if our noble gases already have 8 valence electrons, then they don't need to lose or gain. Okay, so that's why they have a charge of 0. So label the periodic table on the right for the ion charge created as atoms achieve the octet rule, or a full valence shell of 8. Okay, so on our periodic table, okay, let me just zoom in just a little bit. Okay, so on our periodic table, okay, remember group 1 is going to have how many valence electrons? Okay, it has 1 valence electron. So again, you have to ask yourself, is it easier for our group 1 elements to lose that 1 or gain 7 more to have that full octet rule? Okay, so an example, let's use potassium. So potassium has 1 valence electron. Well, if it wants to be a noble gas, its options are argon or krypton. So is it going to be easier for potassium to gain 1, 2, 3, 4, 5, 6, 7 electrons, or is it going to be easier for it to lose 1 electron and become more like argon? Well, it's going to be easier to lose just 1. So if you're losing 1 electron, that's going to be a positive 1. Okay, so this is going to be your oxidation number or your ion charge. Okay, so now how about group 2? You have 2 valence electrons for group 2. So again, ask your question, is it going to be easier to lose those 2 that you already have for this column, or are you going to try to gain 6 more to become a noble gas? Well, of course, it's going to be easier to lose 2. So if you're losing 2 electrons, okay, you're going to have a positive 2 charge. Okay, same thing for group 3, that's going to be a positive 3. Okay, now group 4, you're going to have 2 options because you can either lose 4 or gain 4. You're going to be in the middle. So for group 4 elements, you can either have a plus or a minus 4 charge. Okay, so now we're on group 5A. So if you have 5 electrons, is it going to be easier to gain 3 more or lose 5? Okay, hopefully you answered it'll be easier to gain 3 more electrons. So if you're gaining electrons, that's negative 3. Okay, group 6, you have 6 electrons, so it's easier to gain 2 more electrons. And then lastly, group 7, it's easier for you to gain that 1 more electron to become a noble gas. And then remember, noble gases already have 8 electrons, so they don't need to gain or lose any more. Okay? Alright, so let's go ahead and take a look at our examples. Okay. So helium, okay, again, it's in group 8A, but it's an exception to that rule. Helium only has 2 valence electrons. So our Lewisdot diagram for helium, well, the symbol is He, and we have 2 valence electrons, so 1, 2. Now remember, it doesn't really matter where you put those dots. You can have 1 here and 1 here, or 1 on top, 1 on bottom. It doesn't really matter as long as you have 2 electrons sitting by themselves. Okay, so next question, how many electrons are needed to have a complete outer shell? Well, remember, helium is the exception, so it only needs 2. So how many more do you need? 0. I don't need anymore. So what's your oxidation number or your charge going to be? 0. Okay, carbon is in group 4A, so it has 4 valence electrons, and we've already shown that. So your element symbol followed by 4 valence electrons. Okay, so how many more do you need to have a complete outer shell? Well, you can gain or remove 4 electrons. Okay, so if you're going to gain or remove 4 electrons, well, remember it's going to be plus or minus 4. That's going to be your charge. Okay, fluorine, what group is fluorine in? It's in group 7A. So it has 7 valence electrons. Your Lewisdot structure, well, your symbol for fluorine is an F. So 1, 2, 3, 4, 5, 6, 7. Okay, we're only going to have 1 valence electron that's sitting all by themselves. Okay, so how many more do we need for a complete outer shell? We need to gain 1 more electron. So if I'm gaining 1 more electron, remember electrons are negative, so I need 1 more electron. That's going to be my charge. Okay, and lastly, neon. Neon's valence electrons, it's in group 8A, so we need 8 valence electrons. Your Lewisdot diagram, your symbol is Ne for neon, so again you have 8. So 1, 2, 3, 4, 5, 6, 7, and 8. Now, how many do you need for a complete outer shell? You don't need any. We're happy at 8. We don't need any more than that. So again, my oxidation number is going to be 0. Okay, so hopefully all that made sense. I'm going to go over just one homework problem. Okay, so this entire page is your homework. So page 6 is going to be homework. Okay, so I'm going to do the first one. So lithium is in group number, so that's 1A, so I have 1 valence electron. Okay, your Lewisdot diagram, our symbol for lithium is Li, and how many Lewisdots does it have, or how many valence electrons? It only has 1. So I should only have 1 dot next to my lithium. Okay, so how many electrons must be added or removed to have a complete outer shell? So again, ask yourself that question, is it easier to lose 1 or gain 7? So it's easier to lose 1. Okay, so okay, so if I'm removing 1, I'm removing 1 electron, then that's going to make me a positive 1 oxidation number. Okay, if this confuses you, removing 1 electron, well, that makes you more positive. You guys can always